Chap 5. Try to get done today. It's due today. You can turn it in late for full credit until next Thursday. But try to get done this week because next week you have a whole bunch of Connect Maths due. Monday you have Connect Maths 7174. Tuesday you have Connect Maths 7.3. Technically 7174 should have put it on Sunday, but I thought you folks might have a couple questions about it, so that's why I shifted it over to Monday so you can ask questions on Monday before it's due. Because otherwise I'd have to move it anyways. So kind of think of it as being due on Sunday. So try to get it done worked on a little bit earlier so you can just work on your questions. Make sure your masks are all the way over. I've had another positive student test positive, so I really want the masks on over your noses so that we can all stay safe. We do not want, trust me, no one wants to get COVID right now because we've got chapter 8, 9 coming up, which are important. And after Thanksgiving, we've got 10, 11 that we cover really quickly. So now is not the time to be sick and absent. All right, so masks on, everybody. Keep yourself safe and keep everyone else safe. Okay. And then Thursday, you have Connect Math 818, the first Connect Math week. Excel Lab 7 is also due next Thursday. Again, you can turn it in late for full credit up to a week after that. Okay. Exam 2, again, if it did not go well, I should have those graded this weekend. So hopefully I get them back to you on Monday, assuming everybody has, we're all good with all that. But I should get them graded and posted hopefully this weekend. It might be Sunday at 4 a.m., but I should get them posted this weekend. Again, it's only worth 12% of your grade, so if you didn't do well, that just means you need to step it up and do well on exam 3, especially because chapter 6, everything builds off of chapter 6. Make sure that you work on understanding what's going on in class, not just rotely doing the steps. Right? Make sure that you talk to each other about how do I understand what to do so you can do it on your own. Use the tutorial center. Do your homework. Doing the homework is like, it's really good practice. Okay. All right, next. Lit chocolates. All right, so here's the deal. I have some lit chocolates. I don't have enough for everybody. So if you want one, I have a deck of cards. If you draw a red card, you can have a lit chocolate. So whoever is interested, come on up and I'll let you draw. So, anywhere where you want.
I want to get both. So I just went with the whole outside. I go back. At the whole person goes and my mom's friends. My mom's friends.
They're all black cards.
Our recommend is like 11
Like she didn't win either. Oh! Oh! No one's gonna win.
They're all black cards.
Okay, guys, they are. Social experiment.
I saw on Twitter that one kid like pulled out a card.
Oh, that's cute.
I see it. Go back to the top.
Who's the bottom card?
Four red cards because the deck is red.
Oh!
There's no way.
Choose the bottom card. No.
Because it's
Oh, that's true.
It's actually like there's like Q.
Okay, you
I don't
That's weird. No one got red.
Yeah, no one got red.
Yeah.
So,
Which is cool.
That's odd.
so was there? I felt like there was some talk like that. Maybe it might be like you can never get a red card. When do people start to feel like maybe like there's something wrong with this deck? I might never get a red card. After which draw?
After us.
There's
The third one.
The third one, or what? Anybody feel that after like the fourth person or fifth person? Typically, it's after about the fifth person. Okay, so let's take a look at this. So first, let's have a hypothesis. I'm going to assume that my deck is the same as a regular deck. What should be the proportion of heads? What's the proportion of heads in a deck?
50%.
50%. 0.5. Everybody on board?
Yes.
Now you folks are proposing an alternate theory. You're saying H1, your hypothesis, an alternate hypothesis. You're saying that the probability is less than 50%. Is that what you're saying?
0.
Okay. So this is typically what we do with hypotheses tests. We have, first we're saying our H naught is that your deck is the same as everybody else's deck in the world. So that's always going to be your H naught, that your deck is the same as everyone else's. It equals what everybody else's is, 50%. And then you propose an alternate theory, which is usually the one you're trying to prove. And then you take a sample. We sampled like 8 cards here, right? Does that make sense? We did a sample of about roughly 8. What's the probability that we get a sample like this? What's the probability we get a black card and a black card and a black card and a black card
100%.
and a black card? Well, assuming that this is true. What's the probability the first one is a black card? 0.5. What's the probability the second one's a black card? Third one? Next one? Next one? So and we what? Multiply. Don't say add, because if I add, I get 250%. What the heck? Right? And we multiply. So everybody do that. 0.5 to the 5th power. I want to find it. Point 0.03125. What's our guideline for unusual? 5% or less. Is this 5% or less?
Yeah.
So it's unusual. So as soon as we get something sort of unusual, we start saying, I think there's something wrong with this. So then is it more likely that you just were unlucky and everyone was unlucky? Or do you think it's more likely that H1 is true and H naught is not true?
H1 is true.
Right, so that's kind of the idea of a hypothesis test. We go around, our first step is we assume that our deck or our whatever is the same as everybody else's. And then we take a sample, and then we find the probability of that sample. And if it's unusual, then we say H naught must not be true. H1 must be true. Does that make sense? So typically it's H naught that we're testing. So we're going to say, okay, if we assume H naught is true, then what we got doesn't seem right. You know what I'm saying? Yeah.
So were there any red cards in the deck?
I can't. It could just be you folks are super unlucky. We don't know.
Oh.
However, I've done this several times, or a few times, and the last time I did it, the first couple times I did it, turns out that my students were tormented and scarred for a long time afterwards because I had blank ones in here. I had like regular ones that had paper inside. So since Costco had them on sale, I bought a couple of bags so everybody can pick one at the break.
Oh, we need to start?
You can pick one at the break. So the red ones are milk, the blue ones are dark, the black ones are extra dark, the white ones are white, and the orange gold ones are caramel. No, they have real chocolate in them. All right, so I'm very good you folks figure out.
Trust it though.
Here, I'll pour a few out so you can. All right. Okay, so that's the idea of hypothesis test. We're going to cover starting next week. We're going to get into hypothesis tests, but I wanted you folks to get sort of an idea of them, kind of bounce around your heads before we got into it more. Okay, good deal. Okay, so on to our review of chapter 7. Let's get a reader. Diego.
The simple proportion P hat is the best point estimate of the population proportion
P naught.
P naught.
Perfect. Nicely done. Right, so in other words, what I get from my sample is my best guess at what the whole population is. Right? If 41% of my sample supports Trump, then I expect that 41% of the whole population supports Trump. Right. All right, so problem 1A on your quiz. Sample of 30. So sample of, that's your N. 25% indicated. So your P hat is either going to be a percentage or it's going to be a number divided by N. What did I give you? Did I give you a percentage or did I give you a number? I gave you a percentage. So your P hat is just straight up the percentage. Does that make sense for folks?
Yeah.
So my P hat is going to be 25%, which means that my Q hat is what? 1 minus the P hat, 0.75. Remember, mind your P's and Q's, little p and little q. Either you said yes or you said no. So P hat is the probability, is the proportion of people who said yes. Q hat is the proportion of people who said no. They better add up to 1 or 100% of the population. Right? You gotta get one for the other. Okay, and then what's this at least 3 times? What's the at least 3 times a week? What's that? Yeah, it's nothing. That's the question that was asked. Do you eat fruit at least 3 times a week? Do you eat fruit at least 3 times a week? Yeah. Okay. Do you eat fruit at least 3 times a week? No? Do you eat, yes? So my answers are yeses and nos to what question? Fruit at least 3 times a week. So the at least 3 times a week is the question that you're asking people to get the yeses and the nos. Okay, good. So what's my best point estimate of the population proportion, the actual proportion that everybody in the country is? What's my best guess?
25%.
0.25, yeah, my P hat. If my sample says 25% eat fruit at least 3 times a week, then my best guess is across the whole country, about 25% of families eat fruit at least 3 times a week. So make sure you know this. This is going to be a really, really easy 3 points on the exam, right? People will forget that. It's the point estimate is just your best guess. It's the 1 point, right? Your estimate, so it's related to confidence intervals, just one single number. It's your P hat or your X bar, depending on the situation. All right, so let's take a look at the next part. Confidence interval. So remember, your confidence interval is when you start off with your P hat or your X bar, your point estimate, and then you subtract a certain number of standard deviations and you add a certain number of standard deviations to give yourself this interval between them. So that's what we're doing. We're taking our statistic, our X bar or our P hat, right? P hat in this case, and we're adding and subtracting our critical value, the number of standard deviations that we want to go, our z-score, right? Multiplied by what a standard deviation is. In this case, it's P hat plus or minus our critical value times our standard deviation, which is square root of P hat Q hat over N. You absolutely need to know that. Should be on your half sheet of paper. You're going to need to know, how to find, how to find this and what it is. Confidence interval. Okay. If you did not, I think all of you have this after your notes. Confidence interval is the same thing as an estimate. You're estimating what the population proportion is or what the population mean is. So if I say find the confidence interval, that's a confidence interval problem. If I say estimate, that's a synonym for confidence interval. So it also means find the confidence interval. Estimate, confidence interval, same thing. Please note it may or may not contain the actual mean or proportion. It's our best guess, right? But you may have a weird sample without realizing it. So if you kind of look at this and you see these are all the possible samples that people take, and then you take your confidence interval around them. Most of them will contain the true proportion or the true mean, but every once in a while, without realizing it, you'll have a weird sample. So when you take your confidence interval around your weird sample, you won't get to the proportion of the mean, and you don't know it. So the 95% confidence refers to that's how confident you are that you don't have a strange sample. Okay. Critical values. So remember that's that z-score that separates the usual values from the unusual values. Right? So for example, what's our general guideline for unusual? 5% or less. So usually 95% on the inside, 5% on the outside. So these z-scores that separate the 95% on the inside with the 5% on the outside are called our critical values. And so typically 5% on the outside would be how much in each tail? Yeah, 2.5%, so 0.025 would be this area. So if I want to find that z-score, everybody quickly pull out your calculator and do second bars inverse norm of 0.025 to find this z-score. Second bars, if you have a calculator. If you don't, that's fine. Second bars inverse norm 0.025. What do people get? Negative 1.96, right, when you round. So what you'll find is you get these guys here. I've spelled it out for you, but, right, so you get 1.96. What about for if you have 90% on the inside, you've got 10% on the outside? Remember it's symmetric, so 5% in each tail. So everybody do second bars inverse norm of 0.05. 0.05. Second bars inverse norm of 0.05. What'd you get?
1.645.
Aha. 1.64485. Okay, so really, if I'm rounding to 3 decimal places, it's 1.645. Everybody with me? But if I round to just 2 decimal places, it's what? 1.64. So whenever you're rounding, you have to go back to the original number. You can't round off of another rounded number. Does that make sense? So I can't round from 1.645 to 1.65. I have to go back to the original, which is 1.64485. If I round to 2 decimal places, what is that? 1.64. So next to, on your notes, I'm going to bust out your notes. Next to that, in parentheses, write down 1.64 because you might need that for your homework. Hint, I think you might. I think it wants it to 2 decimal places, so I think you might need to round it to 2 decimal places. All right, let's do this last one too, because that one also has a couple decimal places. So 99% on the inside means how much on the outside? 99% on the inside means how much on the outside? 1%, and then half on each side would be 0.5%, 0.005. So everybody do inverse norm of 0.005. And see what you get. What do you get? Someone help me out. What do you get? 2.57 what? 58. So this would round to what? 2.58. So again, for your homework, you might need to have it to 2 decimal places, so you might need this, 2.58 and 1.64. I'm feeling like that's what your homework uses. So make sure you have notes of that on your table, just like that. Just write them in parentheses next to those numbers on your table. And maybe above that, write for homework, for HW, right? So you know to use it for your homework.